Welcome to the lecture series of Digital Electronic, and today we will discuss the Programmable Logic Array. In short form, we can say that it's a PLA. PLA we will discuss in this session. In last session, we discussed the ROM, and with the help of ROM, we can design any combinational circuit. So the same thing is also applicable in PLA. The PLA is a combinational circuit may occasionally have a don't care condition. Okay. Sometimes in Rome we cannot be considered the don't care. Here we specially consider the don't care condition. Remember that thing. So when implemented with Rome, the don't care becomes an address input line, and that will never occur. So the Rome have a main problem is that we have to cannot be considered the don't care. The word at the don't care address need not to be programmed and may be left in the original state, all zeros or all ones. The result is that not all bits pattern available in the ROM are used, which may be considered as a waste of available equipment. Now let us consider the circuit that converts the 12-bit card to 6-bit internal alphanumeric code. So what happens? The 12 lines designed 0 to 12, the size of ROM for implementing the code convert 4096 to 6. So 12 inputs and 6 outputs require to convert 12-bit card to 16 4-bit. Okay, suppose I have a 12-bit card and convert into 64 6-bit internal programming. So that this thing is that the 4096 to 6, the ROM size it is 4096 2 raised to 12 by 6. This type of the ROM is required, and there are only 47 valid entry. Card entry away 47 only valid. Remaining all are don't care. At that time, ROM are not used because comparison with the 4097 to only 40C valid, the unvalid number or not available number is 90%. So 90% unused ROM use, unused space in ROM. Because in ROM we have to consider each and every combination. So this is the biggest disadvantages of ROM is that it cannot be avoid the don't care condition. And for that, there is another configuration is used. It is known as a Programmable Logic Array (PLA). So in today's session, we have discussed that how we can consider if there is a large number of don't care condition in our combinational circuit, or in such application PLA is useful. More economical compared with the ROM, and it is LSI component called PLA. PLA is similar to the ROM, very similar to the ROM concept. However, PLA does not provide full decoding of the variables and does not generate all minterms in a ROM. Okay, so which two things are not there? Full decoding, not there, and second is there is it is not provided full decoding and does not generate the all minterms. Okay, as in ROM requires. So compare with the ROM. First is ROM have a disadvantages in don't care condition, which can be removed in PLA, while the PLA does not require full decoding and all minterms, which is disadvantages of ROM. So the PLA, the decoder is replaced by a group of AND gate. Let's see the one example. How the internal diagram is there. The PLA is a group of AND gate, each of which can be programmed to generate the product term. The product term is also in the hand of programmer. And the AND and OR gate consider PLA initially fabricated with the links among them. The specified Boolean function are implemented. Sum of product correction. So this is the block diagram of PLA. Let me erase first the above thing is that which we have discussed. So in this block diagram, PLA is shown. The first is AND gate terms, and the input of AND gates are also linked, programmable link. And the output of OR gate is also programmable link. Here it's shown it consists of an input line and M output line and K product term. K product term. So the product term consists of a group of K AND gate. How many AND gates are required? K product term. So K AND gate require. And the sum term consists of a group of M OR gate. Links are inserted between all and input to their complement value input and complement input. Okay, suppose here F dash, all are linked. That means suppose there is a 3 input. So links are 2 into 3, 6 links are there. Suppose there is a 4 input. At that time 2 into 4 F dash. So 2 combinations, 4 input, 8 links are there. And for 5 input, 2 into 5, 10 links are there. So always n into k. K is the number of gates. Suppose there is a this is for one gate. Okay, and suppose I have a how many k gates? So that means there is required 6k, 8k, and 10k. Number of links are there. For each gate, 6 links. Second case, 8 links and 10 links. For each gate, number of gates are k. So 6 into k or 8 into k or 16 into k. That many links are programmable links are at the input of each AND gate. Links are also provided between the output of the AND gates and the input of the OR gate here. Okay. So how many total k gates are there in this side? And this is m. So k into m. Each k is connected to the OR gate. Okay. Another set of links. So link number 1. Here this is link number 1. This is link number 2. And here it is link number 3. 3 stage of links are available. And the third link is that output inverts or allow directly output function. Sometimes suppose it is easy to program f dash, so we get a here f dash and then we have to take the inverted output f. Depends on the complexity of the function. So the output function to be generated by AND or invert. Any one of these things. If the inverter link in a place, the inverter is bypassed giving an AND or implementation. Suppose I just open this link, it will become FS. If I connected this link, it will become F. This gate will become bypass. So here the first question is generated. So how many total programmable links are there in this configuration? Okay, the main question is that because there is a 3 stage of the links are there. First is at the AND gate input. Second links are at the output of the AND gates are there, and the third links at the output of the OR gate to bypass the inverter or consider the inverter. So suppose here in this condition the size of PLA specified the number of input and the number of product terms and the number of output. 3 parameters are there. Size of PLA depend on 3 parameters. 1. Number of input. Second, the number of product term. and third, the number of outputs. These parameters are decide the size of PLA. A typical PLA have a 16 inputs, 48 product term, and 8 outputs. So here we have make the common how many programmable links are there. Okay. So remember that thing, programmable link equal to always this is common. How many? So first is the n input. So 1 plus 2. How many? 2 links are there? F dash. 2n into how many k product terms? So every gate have one. So k. Okay, this is the AND gate level 1 plus. Second is k. Every AND gate have a one link and it is connected to the M gate. So every M gate have a k link. So k into M, second stage, and total M gates. So every output have one link. Remember that thing. Some of the students making mistake here. They consider this is as a link, but it's a inverter gate is that. So every output have only one link is that. It is not two. So plus M. Okay. So this is the common equation useful here. So let's consider 16 input, 48 product term, and 8 outputs. How many links are there? The question is that how many link in this case? So consider it 16 inputs lines are there and 2. So 60 into 2, 32 plus 48 product plus so 32 into 48 is equal to 1536. K into M. K is equal to how many? 48. And how many output? 8 outputs are there. So 48 into 8, it will become 384. And outputs are 8. So here 8 is that. So we have a calculation like 1536 plus 384 plus 8 is equal to 1928. That may be programmable links are there. The answer is 1928 programmable links are there. Let's take one example, programmable logic table array. Suppose a PLA with 3 input line and 3 product terms. Okay. And 2 output lines. Such as a PLA is too small to available commercially. Actually, it is in large like as 16 inputs and 48 products. But to understand the functionality of PLA, we are starting with the demonstration purpose. A very small PLA is that, so we can easily feasible. We can draw the block diagram in the particular area. So we consider as a 3 input, 3 product term, and 2 output lines are there. So here the figure is look like a suppose the truth table is that the function f1 it is given ab dash ac. Okay, the two functions are there. We have to implement with the PLA. So ab dash and ac and second is f2 ac and bc. So according to the truth table, ab dash 0 1. So when here we are considering these three min terms are there and AC and ABC is these two. Okay, so 1, 2 and 3 minterms for function f1, while f2 have 1, 2 and 3 here. While this is the common in both the case, and this one is also common in the both the case. Okay, so PLA table is look like as that product term. How many product terms are there? First is AB dash, second one is AC, and third one is BC. Three product terms are there. So AB dash, first product term, when A equal to 1, B equal to 0, and it is part of F1. It is not a part of F2, this one. Okay. Now, second is the AC. AC, where A equal to 1 and C equal to 1, this contained in both the case, F1 and F2, second term, which is represent in both the case. Both are there. So remove that thing. So here, F1 and F2 both are 1. A programmable PLA, let's take another. The third case is BC, and BC when B and C equal to 1, and it is also part of F2. So there are three distinct product terms, EBDES, AC and BC. The circuit has a 3 input line and 2 output line. So this is called as a PLA table, and it is useful to implement combination circuit. Programmable PLA means that we specify the path of AND or invert pattern. It consists 3 columns. The first column lists the product of term commercially or numerically. Here it is shown numerically, it is in terms of variable terms. The second column specifies the required path between the inputs and AND gate. And the third column specifies the path between the AND gate and OR gate. Okay, this is between AND and OR gate. This is between the second column is between the input and AND gate. Okay, so here we understood that thing. This first product term is connected with the gate number this one. Okay, because three product terms are there. So the B one middle term 0 and this one. We understood that things after the taking the functional diagram or circuit diagram for that. And the third column, as I already told you, between the AND and OR gate. Under each output variable, we write down the true and false. Okay. If output is inverted, is to be bypassed, and C for complement here. Another T and C. Okay. So F1 is 1, 1 and 1. So it is a true. We directly connected this one, and here also we directly. There is no required the F2 dash. Remove that thing. So T means directly, C means complement. Okay. Boolean terms listed at the left are not part of the table. They are included for the reference only. For each product term, the input are marked 1, 0 and dash. Dash means it is not required. Don't get confused. So if it is appear complemented, the corresponding input variable marked with 0. If the variable is absent in the product term, it is marked as a dash. Dash means it is variable is absent. Each product term is associated with AND gate, and the path between the AND input gates are specified under the column heading inputs. The first second column is there. A1 in A1 in this here. A1 input column is a path from the corresponding input to the input of AND gate that forms the product term. Okay, let's see here. This one. So the first A is equal to 1. So A consider. And second is given. The column is that B is 0. Okay. In the second case here. B is 0. A is 1. B is 0 and C is nothing. So the first product term implemented like in this way. A is 1. B is 0, and C is dash. So 1 means directly A. This is the B dash. C here, this one. So this is B dash, and C is not present. Okay, C or C dash. So dash means the input variable is absent in the product term. Each product term is associated. Now second gate. Second gate have A and C. C and second one is E. So second product term, and third product term is BC. So this one is B and C. And C. Sorry, C is the above line. This is the broken line. So here output is PC. This is AC and AB dash. So this is the first stage of link level. And AND gate Z forms of the product term. A 0 is specified the path corresponding to the complement input to the input AND gate, and dash is no connection. Appropriate links are broken. Here the remaining blink, unused blink are broken, remaining and particular links which are required, it is available. The path between AND and OR gate. Now here, the path between AND and OR gate functionality. This one. Let's discuss about this one. Okay. So the column heading outputs. In the previous case, this output, it is decide the which links are open and closed. F1, the product term 1 and 2, and F2 product term 2 and 3 are there. Okay, let's see how it can be established. So here in the F1, the product term 1 and 2 is there, and third is not there. The output variable mark once for all these product term formulated. So here it will become AB dash plus AC, and it is directly, so this link is close. It is not F dash, F1 dash. Okay, so this link will become close. Here it is directly bypass. So we got the F1. The AND gate is bypass. In second case, the AC plus BC. Again, inverted gate bypass and output is F2. Okay, in this way that we got the output. The line is not broken. If there is a line is C, then there is required the broken the particular. So simplify each function in mean terms. Okay, the internal parts of PLA for this circuit, as I already explained the thing, we design the digital system with PLA. There is no need to show the internal connection of the unit. As I already explained that things, PLA table only is required and assumed to be supplied the appropriate path. When implementing a combinational circuit with PLA, carefully investigated must be undertaken in order to reduce the total number of distinct product terms. So here comparison with the OR gate in ROM, there is a 2k into n required, and m's are all product term, while here only require product term, only 3 product terms are there. Okay, suppose there is a ROM, thus there is require 8 gates are there. The circuit is reduced more than 75% in the first level. Similarly, at the output also, the circuit is reduced more than half. So PLA is a specific application, and this can be done by the simplifying each function to minimum number of midterms. Okay, it might be we have to consider the complement sometime. So the number of literal in terms is not important since we have available all input variables. Both the true value and the complement function can be simplified to see which can be expressed fewer product term and provides the product terms that are common to more functions. So remember, the dear friends, in this last series, we discussed the MSI medium scale integration and large scale integration circuits, digital system. The emphasis here was on combinational logic of MSI and LSI. Another part of the digital circuit is known as a sequential logic, MSI function, which we will start into the next lecture. Remember, I think the processor and control unit, MSI and LSI function are part of the microcomputer system, and where the sequential logic is important. The MSI functions present here, other availability of commercial describe the data book. So we have to refer the particular data book of particular company, IC data book, which gives the exact description of the circuit as well as which pin is useful for the which particular application. So data book is very important in MSI, LSI or very large scale integrated IC. So every manufacturer of IC publish a numerous application notes as well as the data sheet of their product. And the list of available application notes can be obtained by writing the manufacturer directly or by inquiry of the other local representative. So in this way, we can also understood the MSI and LSI circuit. To understood more about the circuit's internal functions, please refer the TTL data book for design engineering from Texas Instrument or TTL data book from the Mountain View. Similarly, digital integrated circuit or NECL integrated circuit data book as well as RCA solid state data book series. You can understand that thing, the functionality of MSI circuit after referring the data sheet for particular IC. So I hope here I can conclude the combinational circuit design and we will going towards the sequential logic understanding from the next session. Is it making sense? And have a good day. Thank you very much for listening carefully.